This problem deals with freezing point depression, the concept that the freezing point of a solution is lower than that of the pure solvent. The amount that the freezing point of the solution is lowered relative to the pure solvent is delta TF. So we want the largest value of delta TF, and that will correspond with the lowest freezing point. Quantitatively, delta TF is equal to I times the molality of the solution times KF. KF is a constant value for water. All of these are either water or solutions that are dissolved in water. So the greatest value of delta TF, and therefore the smallest or the lowest freezing point of the solution, will be when the particle concentration is maximized. We have determined we're going to look for the largest particle concentration. So now we look at our choices now, and we need to go through and determine what the particle concentration is for each. And the answer to our question will be the one that has the largest particle concentration. Let's look at our first solution, ammonium phosphate. Every mole of ammonium phosphate that dissolves and dissociates, we have 3 moles of ammonium ions and 1 mole of phosphate ions. That means every unit of ammonium phosphate releases 4 particles in solution. Therefore, our Van 't Hoff factor is going to be 4. Now let's look at the remaining solutions. B, our copper sulfate, ionic compound, metal plus a polyatomic ion. When it dissolves, it's going to dissociate into ions. When we assume 100% dissociation, every unit of copper sulfate releases 2 units of dissolved particles. Lithium perchlorate, I is also equal to 2. Every unit of lithium perchlorate, an ionic compound, dissociates to release 2 particles in solution. D, methanol. Methanol is a molecular compound, we know, because it contains only nonmetals, and therefore when it dissolves, it simply dissolves. There are no ions in this compound, so it does not release ions into solution. Instead, it simply dissolves. The I, the Van 't Hoff factor of any molecular compound, is going to be equal to 1. And finally, our last choice, E, is simply pure water. We know that the answer is not going to be E because the freezing point of all of the solutions, any solution, is going to be lower than that of pure water. Now that we've laid the groundwork, we can calculate the actual particle concentration of all the solutions A through D. Okay, so here are the particle concentrations of these solutions. We get the particle concentration, the moles of particle per kilogram of solvent, by multiplying I times M. Back to our initial question, we want the one with the lowest freezing point, therefore the largest value of delta TF. Largest delta TF is going to be the one with the highest particle concentration, which in this case is going to be choice A. All right, the second part of this question is asking which has the lowest boiling point. This question is presumably dealing with boiling point elevation, the concept that if you have the boiling point of a pure solvent is going to be increased by an amount delta TB when you have substances dissolved in that solvent. Now we want this, in this problem we're asking for the lowest boiling point out of all of these, so of course the answer is going to be pure water. The boiling point of all of the solutions A through D are going to be higher than that of the pure solvent. We'll ask one additional question: which out of all of these 5 is going to have the highest boiling point? Okay, the answer here would correspond to the largest value of delta TB, the highest particle concentration, which again would be choice A.